Okay, so this is the second PowerPoint presentation from chapter 18, and we're going to cover essentially just chapter or section 18.7 because section 18.8 kind of goes along right with this. It's just some industrial applications. So in the first part of the chapter, we talked about how we can use chemistry to produce electricity. And we know that in a galvanic cell, also sometimes known as a voltaic cell, we use a spontaneous reaction that will produce electricity. So electrolysis is the opposite of that. It's using electricity to make a chemical reaction take place. So it's going to be, we're going to put a current through a cell, and make the reaction take place even if the cell potential is negative. And this type of a cell is called an electrolytic cell because it uses energy to produce a chemical change. And actually, this also has a lot of important applications. So this would just show the difference between a galvanic cell and an electrolytic cell. And I want to draw your attention to the anode and cathode on both cells. So in this cell, the anode is a solution of zinc and zinc metal. And the reason it's got SO4 2 minus because that's the spectator ion. But this is the anode. This is where oxidation takes place. So zinc is going to go to zinc 2 plus 2 electrons. And then at the cathode, copper 2 plus is going to form copper because it will be adding 2 electrons to form copper. This is a spontaneous cell, the way that it's written. Now, if you were to switch these and make the copper the anode and zinc the cathode, it would take, the cell potential then would be a negative 1.1. So in order to make this go in the reverse direction, you have to add a voltage or add electricity of over 1.1 volts, and then it will run in the reverse direction. So essentially all you're doing is switching the anode and cathode. All right, so there are some practical applications. The first one is electroplating. And electroplating is a way that it has a lot of actual applications. So you make, and whatever you want to electroplate, you make it the cathode in a tank of ions containing the plating metal, and then you apply electricity. So for instance, let's say we want to make silverware. Now most of what you would buy in the store that we call silverware is really stainless steel or a lesser valuable metal. They don't use silver a lot because it tarnishes and it's not as maintenance free as the flatware that we have now. But if you do want to silver plate something, and in this case it's a spoon, but you could silver plate some jewelry, you would have a cathode, and at the cathode you would have a lesser valuable metal, and the cathode would be depositing silver onto the whatever the lesser metal was. So you've got a bar of pure silver. You have silver ions in solution. This is the anode. You apply electricity, the silver goes into solution, and then the silver ions are plated onto the spoon as pure silver or onto the necklace as pure silver. Okay, so in class exercise 10, we'll be doing an example of this. We're not going to do that right now. I'll do another show me video. All right. So again, I just included, this is the same slide. This has a lot of practical applications. It's how silverware can be made, quote unquote. Is how silver jewelry can be made. You can gold plate if you have a solution of gold ions. This is the way that steel is galvanized. They electrochemically attach zinc they plate zinc ions or a zinc metal onto the surface of the steel to prevent it from corroding. And that takes place in big industrial tanks in a steel mill. All right. This is just an example of the electrolysis of water, where you have water at the anode and cathode. You can separate water into hydrogen and oxygen by applying electricity. And this reaction just shows how much electricity you would need to apply. So we're not really going to go over that into any great detail, other than to say that if you apply electricity to a vat of water, it will decompose into hydrogen and oxygen gas. Okay, we'll do in-class exercise number 11 later on too. Let's look at in-class exercise number, this is not an in-class exercise. Let's look at join-in number 7. Okay, so it says a solution in an electrolytic cell contains the ions copper, iron, and zinc. And it says if the voltage, initially very low, is turned up, in which order will the metals be plated out onto the cathode? Okay, so these are reduction potentials. Okay, so the lower the voltage, the more negative the voltage, the less likely this is going to be to take place, and the more energy it's going to need to make it take place. The more positive the voltage, the more likely it is to take place. So if you start out at a low voltage, they're going to plate out or they're going to plate out in order of voltage from the most positive to the most negative. So starting at a low voltage, copper is going to plate out first. Then as you continue to turn it up, once you get to above 0.44 volts, iron will plate out. And then once you get to above 0.76 volts, the zinc will plate out. And again, this reaction, this first reaction, already has a tendency to occur without adding anything because it's got a positive voltage. So this one is spontaneous in the direction that it's written. So the copper will come out first, followed by the iron, and then the zinc will be last. Okay, another commercial application of electrolysis is the electrorefining of metals. So what they do is they'll take a metal that is present in an ore, and they'll find a way to melt the ore, and they will then pass a current through the melted ore, and it's possible to plate out the pure metal. And we're going to go through an example of that as well in class exercise number 12. So this was a very, very short video. This is it. We are now done with chapter 18. So you should now watch the next show me video, which will go over the in-class exercises 10, 11, and 12.